No, not necessarily. I mean, we'll do a whole bunch of examples, but you could have more than one vertical asymptote, right? You could have vertical asymptotes. Like, let's say you have a function like this: 1 over x plus 3 times x minus 2. Okay, there's two vertical asymptotes there. These factors can't be divided out, and so they do represent x values that are no good. Okay, x can't equal -3 or +2, and so on your graph, at -3 and at +2, you would have this happening. So you could have two asymptotes, yeah. You can just have one asymptote. You mean without horizontal ones, right? Anything else? No, you could. Yeah, you could have a horizontal. You could have a slant. Um, we'll see. Yeah, we're going to do a whole bunch of examples before we make a general statement. I just want you to learn a little bit more about horizontal first, okay? So let me just, I don't want to jump too far ahead on that horizontal, because we're going to get to that real quick, okay? Um, so yeah, obviously if you know this, you could run test points, and so you could find out, hey, where is the graph outside of this, okay? Test points are one good thing. So yeah, so when we explore the vertical asymptotes, the behavior on either side of the asymptotes are the one-sided limits of the function. So are they approaching negative infinity, positive infinity, or whatever? So you want to think about that as one-sided limits as well. All right. You've all been asking about the horizontal asymptotes, so let's take a look at that. So 5.2, little lesson on horizontal asymptotes. Get messy. Okay. All right, so if you're looking at the graph, okay, if you're looking at a graph, and let's say you have a graph like this, okay, what you're looking for on the graph is what seems to be happening, okay, as x approaches positive infinity. So that means what happens as x gets larger and larger and larger. Does there seem to be a pattern that this is actually getting closer and closer to a specific value? And you also want to take a peek to see what's happening as x approaches negative infinity. And so as x gets smaller and smaller and smaller, what is the y value approaching? So in this case, we may have a horizontal asymptote, you know, at about this level for y. Okay? And depending on whatever this is, it's 1 or whatever. So a horizontal asymptote is what's happening to the graph as x approaches infinity and as x approaches negative infinity. Horizontal obviously means flat line. So as I mentioned in the last little part there, a slant asymptote is not a horizontal asymptote. That's something different. But that's what we're looking for on a graph. Now, if we have some kind of graph like this, let's take a look at, you know, y equals x squared plus 2 over x squared plus 1. All right? And you're not allowed to use your graphing calculator, let's say, right? And you're trying to figure out, okay, do I have a horizontal asymptote? And you think, well, what happens if x gets large? Okay, x gets really large. What do these values sort of start to approach, okay, as a y? Well, if you think about this like, you know, let's say x is 1,000,000, okay? And you've got 1,000,000 squared plus 2, and you've got 1,000,000 squared plus 1. These values are going to be really, really close to one another, but this one's always going to be bigger on top, right? It's going to be bigger on top. So it's going to be a huge, huge number. This one's always going to be a little slightly bigger, but what's this number going to be pretty close to? Close to what? Close to what? 1,000,000 squared plus 2 divided by 1,000,000 squared plus 1. It's going to be really close to 1. Is it going to be under 1 or over 1? Close to 1, but slightly larger. Okay? So you would be able to logically think here, well, this one, if I substitute a really large value in, they're going to be super close to one another because they're both squared. this one's always going to be 1 unit larger up here. So it's going to be very close to 1, but slightly larger than 1. So as x approaches infinity, it appears that we have a horizontal asymptote of 1. And is the graph going to be above that asymptote or below? Well, at 1,000,000, the graph's going to be up here above it. So it looks like it's going to come from the top. So these are all pieces to the puzzle you're putting together, right? As x approaches negative infinity, so what if this is a really large negative, like negative 1,000,000, negative 1,000,000, and we're squaring it and so on, we get the exact same value, right? So it's coming from, whatever. So it's also approaching this horizontal line of 1, okay? So that's thinking logically. I am going to present to you today a method of taking a look at any rational function and finding out what the horizontal asymptote is, okay? So we're going to use the fact, we're going to use the already accepted limit that we have, that limit as x approaches infinity of 1 over n equals what? What does that equal? As x gets larger and larger, sorry, I wrote x and I wrote n here. X, 1 over x, what happens to this value as x gets larger? Okay, so this approaches 0, right? The limit of as x approaches infinity of 1 over x is 0. We're going to use that. So let's do an example. Let's say, what is the horizontal asymptote, or what is the value of the limit as x approaches infinity, now we're thinking calculus here, of this particular rational function. Okay, 4x squared minus x plus 2 over 6x squared plus 5x plus 1. Okay, this one's a bit tougher. You say, well, what happens if I put 1,000,000 in here? Okay, well, you're going to have 1,000,000 squared times 4 minus 1,000,000 plus 2. And on the bottom, you're going to have 1,000,000 squared times 6 plus 5,000,000 minus 1. That, I mean, that's a bit tough. So how do we figure that out? I mean, is it 1? Is it the same as the other one? Or is it something a little less or something a little more? Tough to tell. So this is what we do. And tell me if we did this in Chapter 1, because I have a sneaking suspicion that we've done this already. Yeah, I'm almost 100% sure we did this already. Do you remember how we simplified in this and using our limits here, using this whole idea by dividing each term by the largest degree of the variable? Yeah, we did that, didn't we? Oh, sweet. Okay, so we're going to do the exact same thing that we did in Chapter 1, except now we're going to realize that, hey, as x approaches infinity, what this limit is going to be is the horizontal asymptote. Mind blown. Okay, you guys look really excited about that. Yeah, not really. Okay, just checking. So everything divided by x squared. You confused? Did I hear that?
So does it equal x asymptote after we find it?
Once you find this limit, we're going to find this limit, and that limit is going to be the horizontal asymptote. So it's going to be y equals whatever this limit is. Okay? So what we're trying to do, again, using these limits, we're trying to find what is the value of this rational function as x approaches infinity. This is why we learned how to do this in Chapter 1. Because really, we want to know what value, if any, is this graph approaching? Is it approaching this value? So is it doing this? You know what I mean? Coming up to this value. Is it approaching, or is it approaching this horizontal value? You know, is it doing this? So we're trying to find out what value it approaches as x gets really large. Okay? So this simplifies to the following. 4x squared divided by x squared is just 4. This is minus 1 over x plus 2 over x squared. This is 6 plus 5 over x plus 1 over x squared. Everyone with me so far? Now if I apply my limit rules, okay, and I'll just do this once just to show you exactly, and it's a lot of writing, but let me just show you, okay, so you take the limit of each individual term, and again, I'm just going to show you this once, right, so that we can see this. You don't have to do this every time, but really you're just finding the limit of each individual term here. That's on the top, and here's the bottom. Over x plus the limit as x approaches infinity plus 1 over x squared. Okay, so that's, we can do that. That's kind of properties of limits there. And now what we see when we apply this, okay, the limit is x approaches infinity of 4. Well, that stays as 4, doesn't it? X doesn't affect this. It just stays as 4. This one is 0. This one over here is like the same as this right here is the same as 2 times 1 over x all squared, isn't it? That's what that means. Which this, as x approaches infinity, this becomes 0. So 0 squared times 2. Big deal. That's 0. Okay? Is this ringing bell from chapter 1? Awesome. Okay? So down here, that is 6. The limit is x approaches infinity of 5 over x. That is 0. 1 over x squared, that is 0. So guess what? We have a limit of 2/3. And that limit tells us what the equation of the horizontal asymptote is. So the horizontal asymptote, and I'll just review that, HA is fine, is y equals 2/3. Let's confirm that with the graphing calculator. So you each have one. Okay, so now, of course, this is why we can use our graphing calculators to check our math. So that's all good. All right. So again, let's get that equation up there. Okay. All right. So you're gonna have to use some brackets and everything, but this is 4x squared minus x plus 2 bracket divided by bracket. Check that out at the bottom. Okay, so you get that typed out there. I think that's correct. Okay, and we graph it. Now, this is the window that I had before. Okay, so it looks like we have a vertical asymptote here. That would make sense because there's some x's in the denominator. But the horizontal asymptote, now let's just get this, let's change this window here. Okay, so an x minimum. Let's just go to -5 maybe. X max. Let's make this really big, right, so that we can see what's going on. Let's make it like 100 at least. Okay, y minimum. That's the bottom part of the scale. We're looking at 2/3, so let's just make it 0. Okay, we don't need to see too much of that. And the y maximum, let's make that 1. So this is the window setting I have here. -5, 100 for x min and max, and so on. And when I graph that, okay, so remember, this part right here, this is, going to be about 1 up there, right? This is 0. So, and this is 100. So do you see how this graph, it seems to be leveling out, right? It seems to be leveling out. And let's just see, let's do calculate a value, and let's put in x equals 98 and see what happens. Oh, look at that, 0.659. That's under 0.667. So it appears that maybe this is getting closer and closer and closer to 2/3, 0.667. Okay? Questions? Drawing. So remember that when you're finding the vertical asymptotes, again, if you have, like, let's say you have 2 over, x squared plus 5x plus 6, and you say, well, I don't know exactly what x value would cause it to be 0, always remember that you can factor this, right? X plus 2 times x plus 3. Or use the quadratic formula if you need to. X equals negative b plus or minus root b squared minus 4ac all over 2a, right?